Hi, welcome to this new tutorial. Now I want to show you how to model a movable operator. This is very common in any production process. So in order to do that, we first start to place different items from the standard library to create a layout for our process. So let's say that we have two sources, source number 1 and source number 2, that we have associated servers, server 1, server 2, and that we have a sink somewhere here. We connect them with a classical path. Double click and connect input to output as we typically do. So like this, perfectly. So now we want to drag and drop also after we recenter the model, two model entities. So this will be part A, which is produced by source number 1, and this is going to be part B. Part B. Very importantly, I want to color part B with a different color in red in order to recognize it. So now I want to create something that basically allows me to say to SIMIO, to communicate to SIMIO that every time something arrives here, in order to be processed, you need a person, a human, to perform a task. So we need to model this movable operator. It's movable because the operator is moving from server 1 to server 2 and back every time something is needed to be processed at the different servers, the worker need to move up and down. So in order to model an operator, we have an item in the standard library which is called worker. So we drag and drop the worker inside here. This is called worker number 1. So now we have to communicate to SIMIO that we want the worker to move between server 1 and server 2 up and down every time something need to be processed. And we also want to tell SIMIO that the distance between server 1 and server 2 is exactly 20 meters. So this can be done by using a path. So we model a path in between server 1 and server 2, and we tell SIMIO that this path is exactly 20 meters. So we can, for instance, use a node in order to create the path. This is a case where it's allowed to create, for instance, a link in between an input to another input. So we create the path upon which the worker will walk in between the different servers. So please note that every time we create a path, this is unidirectional, but we want the worker to move up and down this path. So the type of path is not unidirectional, but we need to change it to bidirectional in the properties. And now sort of we have a path upon which the worker will move. So we can have a look at the worker now. Very importantly, now we have to tell SIMIO that worker 1 is moving on the path. So we need to click on worker 1 and have a look at its routing logic. So we have a resource logic, we have one worker, so fixed capacity. We have a desired speed of the worker. This is actually something that probably we need to modify. So in a production line, I think a worker should not be expected to walk more than 3 kilometers per hour in terms of speed. So we can change that. So in this case, we have by default an initial desired speed for the worker, which is 2 meters per second. We can change it to 3 kilometers per hour very easily, like this. And then we have a routing logic. So we have first to communicate where the work starts in the morning, when he or she starts with his or her shift. So we have an initial node, which is home, where the worker will start, and we can select the node that we prefer. So we have two nodes along the path, the input to server 1 and the input to server 2. I think I will go for the input of server 1, just logical like this. Then we have also to specify what is happening to the worker where the servers are idle. Is the worker expected to just move up and down to this path or just to stay at the node? I think the idle action that is most intuitive is to remain in place. And when the shift is over, when the 8 hours of work are over, we go back and we park at the node to represent the fact that we are not longer working. So this is not enough in order to tell SIMIO that the worker needs to be there in order for the server to perform the activity. We also have to have a look at the servers and change some properties from the server themselves. So we go and click on server 1, for instance. We are not very interested right now on the processing time, on the buffer logic, etc. That you can change as much as you want later on. But I'm also very interested about the secondary resources that are needed in order to perform an operation. So we click on the plus here for secondary resources, and here we have a menu that essentially is used to communicate to SIMIO the need for having a worker there. So what we need to do, first of all, I just change repeat group from true to false. We don't have any group, so it does not make sense to use that. So if I click false, a new menu opens up, and here I can specify the specific object that is needed in order to perform the operation. In this case, I want a specific object, and the object name is worker1. He or she is the one that I need. Then I have a selection goal, which is essentially trying to understand which worker should be sent to a particular server, and is particularly useful when we have more than one worker. So in this case, we don't have any preferred order or any specific preferences because, it's just one worker. But what we want is we want that the worker moves to input to server 1 because it's there where the worker will operate. So in this case, I ask the worker to move to that node, and I enter the destination node input server 1, which is exactly this node here. And what happens then when you basically terminated your 8 hours of work and you're still processing one item into one entity into the server? I think the most logical way to terminate the working day is to finish the work already started. So we modeled the fact that we need a worker there to perform an operation. We repeat the same process for server number 2. So we go here, we go down to secondary resources, we change repeat group to false. We have a specific object that we need, is always worker1. And we have a selection goal, we don't care about it, but we need to request it to move to request him or her to move to the node. The destination node in this case is the input to server 2. That is basically the only difference. And we also want to have the worker to finish the work already started at the end of the shift. So let's now try to run the model and see what happens. So there is a small thing we need to do again. We have to stop the model. And we have to tell source 2 that the entity type that is arriving is not part A, but part B. This is a classical mistake that I always do, and everybody does. So we run, and now you see the items are accumulating, and they are waiting for the worker to go up and down and to process them in order to go to the sink. This is very useful to model a number of different activities, operations, tasks in a manufacturing site.